Okay, we've established then that the osculating circle for this point is the circle centered along the line through this point parallel to your A perpendicular at a distance rho equal v squared over A perpendicular, v squared over centripetal acceleration, v squared, well, yeah. So that's easy to do. Let's see how we would go about calculating the equation of your oscillating circle. Okay, let's clarify a couple of things now. The point on your curve is identified with r of t, whatever your t is that puts you here. That's the point on the curve. Okay? So, the center is where? Well, here's your origin, here's your origin. Your r of t vector would be from here to here. Now I've got it here, okay? So here's your curve, here's your point, here's your r of t vector. Okay, here's your unit normal vector, and you move along the line of that unit normal vector through this point a distance equal to the radius of the circle, and there's your center. Okay, well, how do you move a distance equal to the radius of your circle along your unit vector? The vector you move along is just your radius times that unit vector. So your yellow vector that goes from here to the center of the circle is just your radius, which is rho, times your unit normal vector. Okay, so to get from the origin to here, you go from the origin to this point, and then follow the rho n vector to this point. That means that the vector from the origin to here is your r vector plus your rho n vector. Well, you identify the r plus rho n vector with the point it ends at, and you have the center of the circle. Okay, so center of the circle is at r of t plus rho n. Now, again, assuming you've calculated everything up to this point, you'll have an expression for this. And you'll know what that point is. Now, you want to get the equation of a circle centered at a point that you now know, but you have to know how that circle is oriented in space. It's not in the necessarily in the xy plane or the yz plane or the xz plane. Where is it? And what's its orientation? Well, the plane that it's in is a plane that's through the r of t point. In other words, this x of t, y of t, z of t point. How do you define the direction of a plane? You define it by the normal vector. What's the normal vector? Well, we saw it before. And somebody came up with it. You know, took 20, 30 seconds, but somebody said, well, okay, yeah, that's going to be your binormal, isn't it? Yep. Why is it the binormal? Because your unit tangent is in the plane of motion. Your unit normal is in the plane of motion. So your circle has to be in that plane. The binormal is perpendicular to both of these vectors that are in the plane, and these vectors are perpendicular. Their cross product is certainly not zero. Matter of fact, these are unit vectors and they're perpendicular, so the cross product is a unit vector, and that cross product is your binormal vector. So again, unit tangent, unit normal, binormal. Moving around with you. These two define the plane, but their cross product is the thing really used when you're getting the equation of the plane. So, we know what the plane of the circle is, we know what the center is, and we know what the radius is. So that ought to be simple. Well, it turns out it's not all that simple. So let's see where we go with that.